Alright, other one is 1.3. Let's take a look at 1.3. This one was not completed, so we'll wrap it up. Let's take a look at 1.3. We have 2x plus 1 and then plus 2 to the power of x must be equals to 3, and then we have y plus 2, and for a bit of space, and then we also have minus 3 minus 3y. It's the same problem, yes. And then the question is saying, if we look at the question is also saying to us, where x and y are integers, we must determine the value of x and y. It's just 3 marks, so not much work is needed. And then let's go back to the problem. Here's our problem. I hope it's clear. And then we are going to simplify both. So we'll use the laws of exponents to expand the side. I'm going to expand this, and this will be the same as 2x multiplied by 2 to the power of 1. This is 1, and then plus 2 to the power of x, and then on the other side we are going to expand this, so it's going to be 3 to the power of y multiplied by 3 to the power of 2, then minus 3y. Yes, we are expanding. We are reversing this law of exponents. Let's say a multiplied by a. If this is 1 and this is 2, this will be the same as a. Then you keep the base and you add them. So this is just the reverse of that. So we are reversing this. We are reversing this to actually give us that. Reversing that to actually give us this. Fine. Good. And then we are seeing that when you look at this, the left hand side, we have a common factor. The side of 2x, also a common factor of 2x. We're going to take out the common factor, which will be 2 to the power of x, then open bracket, will be left is 2 to the power of 1, then plus, and because the common factor is out, we just be left with 1. And on the other side, we have 3 to the power of y, and then we open the bracket, we'll be left with 3 to the power of 2, which is the same as 9, and then minus 1. And we move again a bit, and just go up a bit for space. Let me erase this previous question quickly to get enough space. Good. And then now we'll simplify inside the bracket. When you simplify inside the bracket, we'll have 2 to the power of x. Then this will be the same as 2 to the power of 1, which is 2 plus 1, it will actually give us 3. And then we have 3 to the power of y this side, and 3 to the power of 2 is 9, minus 1 will actually give us 8. So what I will do, I see that I have 2 multiplied by 3, so it's 2 to the power of x multiplied by 3. Let me keep it that way. And on the other side, we have 3 to the power of y. Then this is 8. So if we write 8 as a factor of its prime numbers, prime factors, it will just give us 2 to the power of 3, which is the same as 8. Now, using comparison, you see that we have a base this side with the same base, a base of 2, also have a base of 3. Even this side we have a base of 3 multiplied by the base of 2. So the bases are the same on both sides. The combination of the bases are the same. So it will be evident to say, now let me move up a bit to say, okay, since on this side I have 2 to the power of x, it means this must be equals to that. This must be equals to this, and this one, let me use red, and this one must be equals to that one. So if this is equals to that, and this must be equals, also must be equals to that. So we can say it means the exponents must be the same. So x must be equals to 3, and your y must be equals to 1, because 3 is the same as 3 to the power of 1. And that's our solution for